let's see. All right, hopefully everyone can hear me. So happy Good Friday. So let's continue on our notes. So class,
Yes.
I got Christian here and Tree, but Tree doesn't play along with others. So we're gonna go through indefinite integrals using substitution. So it actually makes life easier, so you don't have to sub backwards and then try and solve it. So we just change the bounds. That's what this is gonna do. So we know how to plug it back in, right? We know how to plug it back in. So this is the one that I'm going to focus on today, is changing your bounds. All right, we did this one already. Not there. Here it is. We did. Oh wait, no, this one's x squared. Where did we do it? I could have swore we already did it. Oh, okay, I might be just losing my mind.
You did.
Most likely. I did not do that same. Okay. Anyway, so I'm going to say that my u is going to be equal to 4 minus x squared. Du is equal to negative 2x dx. Alright, and divide by 2, negative 2. So x dx is going to be replaced with negative 1/2 du. So I'm going to have negative 1/2 out front. And then that's going to change to, get rid of that. This right here is going to be u to the 1/2 du. And if you notice, I did not write my bounds. So I'm going to show you how to change the bounds real quick. This is actually super easy. Do you have a question?
Just type C. Good.
Would you like to ask me if you could use my charger here, or just, scavenge from whatever you find on my desk?
Both. Okay, use the charger.
Yeah, here. Alright, so, right here. So in this case, my x is supposed to be 2, right? So let's u sub that. So if x is 2, that would be u equals 4 minus 2 squared. So my u is going to be 0. And the other one is going to be u equals 4 minus 0 squared. So u is now 4. And so what did this really do? It's that fundamental thing. It's that fundamental thing here. What did that do right there? Did it change my bounds, right? And so it flipped them, didn't it? So now, so I could flip it back and change that to a positive 1/2 out here, couldn't I? So I could, but I just want to show you as is and show you where it all goes. Anyway, let's take the integration. So I get negative 1/2 still. And that's going to be u to the 3 over 2 times 2 over 3 from 4 to 0. So if I plug in 0, my upper bound, wait, 2, plug in 0, I get 0, right? Minus lower bound. So my lower bound here is going to be 4, so 4, square root of 4 is 2. 2 to the third power is? Yep, very good, 8. So I'm going to have 8 right there. So it's 8 times 2 over 3. see, that's going to be a negative over here, 0, so it's going to be negative 1/2 times negative 8 over, no, 16. Because there's that 2 right there. 16 over 3. That will, 2 negatives will make that a positive. And the 2 and 16 will cancel, so that will give me a positive 8 over 3. Is that a good one right there? You alright? Feel solid about that one? I saw the mic drop right there. So yeah.
For the top right there, was that still relevant to the problem, or were you just showing me just like how we would move about change?
Are you talking about this?
Yeah, like how when we change like the bound right there.
Yeah, this is changing the bounds. So now, when I do this, all I did is I plug this in
Right.
to whatever my U was. So these are now U bounds. After I change it, it's no longer X bounds, it's now U bounds.
Where's the 0 go?
Which 0?
0, 4. Left. That one.
This?
Where did it go?
What is 0? What's the square root of 0? For those people watching on YouTube, he's making the Nico sign for some reason. So, square root of 0 is, then raised to the 3rd power,
You're not ready for it. It's 1.
and then times 2/3.
It's 1.
I guess in this problem, we don't see the problem. Alright. Alrighty. Same thing here. Now, again, I normally want to decide what it is that I want to actually sub.
Surely we're not gonna use the trick that Andy.
Say what again?
Surely we're not going to use a trick like him.
Why not?
Okay.
Okay, even better. So, what would I sub? 2 theta, yeah. So now I'm gonna have a 1/2 over here, but isn't this also a 1/2? So I could factor that 1/2 out and this 1/2 over here to be 1/4. And now it's gonna turn into 1 minus cosine of u du. Alright, let's go back over here. So pi over 2, so I'm gonna change my theta bounds to u bounds. Pi over 2, so pi over 2 times 2, 2 pi over 2, which gives me just, yep, 0. 0 times 2, so I get 0.
Oh, so you have to like both your upper and lower bound.
Yeah, and so now we have new bounds. So now I don't have to substitute this back to go plug in the bounds. So this actually makes your life a whole lot easier and it's a lot quicker. Alright, let's take integration, so 1/4 times, what's the integration of 1? Yeah, and antiderivative.
X.
It
Or
w-
U.
Yes, there we go, u. See if I can catch you on that. So yes, you were saying, you got it with the x, but we're using u's. Alright, so, integration of negative cosine, is going to give me every place that there's a u, I'm going to put in
Isn't it pi? Isn't it plus sign?
pi, right? So get pi
Is it plus sign?
minus, what's a plus sign?
U plus sign.
What was that? Alright, so derivative goes this way, antiderivatives go the other way, right?
Oh, yeah, wouldn't it be a
We're
plus
doing
sign?
anti. I forgot.
Oh, no.
So this is an integration here. So if you remember it as the wheel, is that what helps you, Christian? The wheel?
I
Yeah.
get it.
Yeah, that's the only way I can actually remember all the way through. I have to imagine the wheel. Alright, so there we go. And sine at pi?
Is it 0?
Yep. That's the top minus the bottom. This is gonna give me
Sorry, I'm trying to write down stuff. 0 minus 1.
what is sine at 0?
0.
Yeah, it is 0. So 0 minus 0?
0.
There we go. So all this gives me a grand total of
Pi.
anything else?
Pi over 4.
Very good. Good job. So how do you feel about this? You feel pretty solid about this?
Is it like a specific like instance we like can use this, or can we just use it for like anything really? Like as long as it's in this one.
Any of them. Any that you have bounds that you have to use so.
How do we know like when we have to use it though?
Okay, see this right here? Is that a chain rule?
Oh, okay, so anytime it's a chain rule.
Yeah, if you look at it, say derivative. Oh, chain rule, then you're like, okay, even though it's an antiderivative, when I use a chain rule, I want to actually, be able to do a u sub on it. Alright, integration, evens and odds. First one's gonna be even. So, even, I could see right here. This is gonna look like this, so it would be finding the area. It would be basically from 0 to A times 2. Because isn't this symmetrical? Okay, what about this one? This one is not symmetrical. And can you give me a function that this could look like? Yes, you can. What's the simplest shapes? Okay, let's look at this one. What if this one is just like this? That is a parabola you get from what? X squared. Okay, this shape right here is not a parabola, but what could I get that shape from? How about this? I'm just doing for the sake of argument, it doesn't actually fit. Isn't x cubed like this? Depending on the shape of the graph, it's gonna tell me if it's gonna be even or odd. Because if this is the graph here, I'm gonna have some negative down here, and I'm gonna have positive up here, and so those should cancel out to be 0. Over here, I have all positive up here, or if it was negative, it would be all negative, and then the same on both sides. So it would be symmetrical, even if my parabola was going upside down. Okay, like this. So if it was going like this, it would be all negative, so it would be 2 times whatever one of the symmetrical sides are. Continuous, they're there, and if it's an even function, then we get 2 times because they're symmetrical. It's an odd function, we should get 0.
Whoa.
Alright, Christian, we're gonna do this, and we're gonna do it without doing the math. You're gonna mentally look at this thing. Okay, you're gonna break it down. You're gonna do calculus in your head right now. Hey, what's that gonna be?
For the upper bound,
No.
or?
You're not up bounds. You're just gonna do the calculus in your head. Tell me if this is even or odd.
Even, wait, odd,
Why is it odd?
because of the, oh, the degree.
The degree? What's the degree here?
Isn't it 11?
Is it what?
Isn't it 11?
That's a 7 right there.
Yeah.
So the degree, the highest
Oh.
one in there is the one that controls the shape. So the degree of all of it together, of each one individually, but this is gonna be of 7. So a 7th degree means that it is odd, so it's gonna be somewhat up and down shape. It's going to do, the left side's gonna end at negative infinity somewhere, or right side's gonna go up positive infinity. So this is gonna be an odd. This one right here
Even,
why is it even?
because of the degree.
X to the 4th. It's even. I think in the book they actually did the. Did they do the math on it? Yeah, they did the math just to figure out if it's even or odd, but that's not necessary. Alright. If f is an even function, okay, f is an even function, 0 to 2 is equal to -6. From -5 to 0 is equal to 8, and 2 to 5 is something. Okay, every time I see one of these, I do number lines. I really do. So from -5 and then 2 and I'm looking for 4, 5. So from here to here is -6. Are you still drawing?
Yeah, I was drawing that one.
Okay. Are you ready for me? Okay. So from there, there's -6. And from -5 to 0 is 8. So if it's an even function, I should be able to say that from -5 to 0 is going to be the same as what?
At 0 and 5.
Okay, so from -5 to 0, it's the same as saying 0 to +5. And if -5 to 0 is 8, therefore 0 to 5 must also be 24 from 2 to 5. That's where I need to look at. So this is what I need to find eventually. So the sum of the parts. So I should say, by doing segment addition, I should say from 0 to 2 plus 2 to 5 is equal to 0 to 5. So this is way back in geometry, segment addition, but usually we label it as like AB, BC, all those. Okay. So 0 to 2 was -6. Plus 2 to 5, which is, I don't know. Right? That's what I'm looking for. So in algebra, what do we represent I don't know with?
X.
Very good. And all that has to equal my 0 to 5, and my 0 to 5 came out to be 8. And now, there we go. So, add 6 to both sides. So, x equals 14. Does that help out or no? I can actually go so far as to like do A, B, C and all that to do the full segment addition if you care. No? You're good? Okay.
For if it would be an odd function, but
We would know that this from -5 to 0 would what?
-5 to 0 would be negative, or
Would be equal to -0 to 5. The reason why I say a negative, it's opposite. So whatever this is, so think of it like this. So in this same sense, that would be, this one would be +8. The other side would have to come out to be -8. Because when we add the two together, they equal 0. So that's the way that I would do if it's an odd function. Sound good? Great question though. All right, like, share, and subscribe. So that means homework is due on